Hello and welcome to another video. In this video, I'll be covering log laws. This video is closely linked to the previous video that I made on the series because logarithm is the inverse of exponent. Without further ado, let's start. After watching this video, you'll be able to learn more about log laws and also learn how to use them in questions involving logarithm. Before I cover the log laws, it is important to go through the basic principles of logarithm. As I said in the beginning, logarithm is the inverse of exponent. What that means is, like for example, subtraction is the inverse of addition, division is the inverse of multiplication. Here is how to convert between exponent and logarithm. So on the left hand side here we have y equals a to the power of x. This is an exponent. And we add a log base a for both sides, and we have log of y base a equals to x. So this is the logarithm, and what this means is a to the power of x equals to y, which is the same as this one. For logs, there are bases. For example, here the base for this log is a. There are two common logs that do not have a written base. The first one is base 10, which is written as just log. The second one is natural log, written as ln. The base is e, which is Euler's number. Euler's number is a mathematical constant. In some calculations, you may have different solutions for your answer. In this situation, you may need to consider the domain. So here is a log graph y equals log x, and the graph only goes to the positive x direction. So what that means is 10 to the power of y will not give a negative x number on this side. So if you have a negative value as one of the solutions, that solution will be rejected. Here are the log laws. Some of them connect closely to the index law that I've covered in the last video. Same as the previous one, I suggest you to memorize the laws. The first and the second one are related. For the first one, when I have two logarithms with the same base and different number, and I add the two logs together, I can combine it into a single logarithm and the numbers will multiply together. For the second one, if it's a minus, then the numbers will divide. For the third one, when I have a power for the number inside the log, I can bring it to the front, so it will be the power number, in this case is n, times the logarithm. Note that the power is for the number inside the log, not the whole logarithm. For the fourth one, this is related to the basic principle of logarithm. It's saying a to what power gives a, and that's 1. So log of a base a, or log of a number and the base is the number itself, and it will be 1. Now same logic, if it's log of 1 base any number, then it will be 0 because any number to the power of 0 is 1. For the fifth one, it's similar. It's saying a to what power gives me a to the power of m, and that is m. For the sixth one, exponent and logarithm are inverse, so they cancel out each other like this to make only m. For the last one, this is what we call change base formula. If I have log of x base a, remember all of these are constants, and I want to change the base of the logarithm, I'll have log of x base b, another base, over log of a base b. One good method to memorize is that the number is on top of the base number, so it will be on the numerator, and the base is lower, so it's on the denominator position. Note that this is different from the second rule because this one has 2 logs, but the second one only has 1 log. After covering all the log laws, it's time to apply them in questions. Here are 3 questions in which you need to rewrite the expression into one logarithm. You may pause the video now to solve them. I'll solve them in 3, 2, 1. For question 1, these 3 logs have the same base and they are adding together, so we can combine all of them into one log directly. The numbers will multiply together, so our final answer is log 24. For question 2, we have the same log bases again, so we can combine them directly. The minus here means that we are dividing, but the plus also means it's multiplying, so we have log of 30 divided by 2, but also times 5, so we have something like this. Simplify, and we have log 75. For question 3, we don't want this coefficient in front of the logarithm, so we bring the power up to have log of 2 squared, so that will be log 4. And for the constant 1 here, we can rewrite it as a logarithm, and we know that logarithm here is base 10, so we can rewrite 1 as log 10. Now we have log 4 plus log 10, they have same basis, so we can multiply the number. Log of 4 times 10, that is log 40. This is another type of question. Simplify these expressions and rewrite it as an integer, which are whole numbers. You may pause the video now to solve them. I will solve them in 3, 2, 1. For question 4, we have same basis again for the logarithm, so we can combine them directly. So this is a minus, so we divide the numbers 8 divided by 2, so that's log of 4 base 4. We can further simplify this because the number is the same as the base number, so it will be 1. For question 5, we don't want the coefficient in front of the log, so we bring it up as a power, and we rewrite 3 squared as 9, so we are at this stage. We can combine both logs directly because they have the same base, so we have log of 36 base 6. Now saying 6 to the power of what gives me 36, and that's 2, because 6 squared is 36. So our final answer is 2. Here is a harder type of question in which you need to solve for x. You may pause the video now to solve them. I will solve them in 3, 2, 1. For question 6, the log bases are different for the left hand side and right hand side, so we need to use the change of base formula. Based on my experience, I do not like having a fraction for a log base, so I'm going to use the formula on the left hand side, and we're going to change it to base 9 because the right hand side, the log is base 9. So this is how to use the change of base formula. So it looks something like this. So the denominator, the 1 over 9, we can rewrite it as 9 to the power of negative 1, and then we can rewrite this log as negative 1 because it's saying 9 to the power of what gives me 9 to the power of negative 1, and that's negative 1. So we can further rewrite to something like this. And now the negative 1 coefficient, I'm gonna bring it to the power. So it looks something like this. So now we have 1 log for both sides, and both of them are in the same base. So we can cancel the logs out because it's basically saying x to the power of negative 1 equals to 5. But what actually happens is that both of them are in the power, are 9 to the power of the left hand side equals 9 to the power of the right hand side. So what this does is to cancel out the log. So now we have 1 over x, that's x to the power of negative 1 equals to 5. So x is equals to 1 over 5. For question 7, this is a tricky question because it involves some quadratic calculation. First thing I do is to combine the logs on the left hand side because they are in the same base. We can combine them directly. So it's a plus, so we multiply x and x plus 1 to make something like this. So now we can cancel the logs out. So we have x times x plus 1 equals to 56. Expand the brackets on the left hand side. Then we subtract 56 on both sides. So we have one side is 0. So now we have x squared plus x minus 56 equals to 0. This quadratic can be factorized, so it will make something like this: x plus 8 times x minus 7 equals to 0. To solve for x, we say x plus 8 equals to 0 or x minus 7 equals to 0. So we have x equals 7 or x equals negative 8. So now the domain for the log function comes into play. Because let's say we are having log x. If we sub in -8, it means that 10 to the power of a number equals to -8, but it's not possible because 10 to the power of a positive number, it will give out a very big number, but for to have 10 to the power of a negative number, it will be a fraction. Therefore, the -8 solution will be rejected, so our final answer is x equals 7. For question 8, it is involving natural log, but don't be scared with this thing, it's just a log-based e shortened, so treat it as a normal logarithm. So same base, we can combine it directly. So on left hand side we have ln 5x. On the right hand side we can rewrite 3 as ln e cubed using the rule I mentioned before. We can cancel ln for both sides, we have 5x equals e cubed. Divide by 5 on both sides, so x equals to e cubed over 5. In this case, it is not necessary to evaluate this number. It is best to leave it as an exact value. Here are some tips when solving questions involving logs. Try to make the log bases the same and also make both sides having one logarithm. If there are any integers, rewrite them as log using the rule I mentioned before. These tips help you a lot when doing log calculations. That's all for this video. I hope you enjoyed and learned something from here. Please consider subscribing so you get notified for future videos. Thanks for watching. I'll see you soon.